And good day, Algebra. We are wrapping up our unit with CO43, wrapping up the binder as well. Worked out perfectly last week, the last objective of the binder. Your test won't be till next week because we are having a retake day in class on Thursday. But we're closing with a system of inequalities. We've spent so much time on a system of equations, right? We solve them by graphing, we solve them by substitution, we solve them by elimination. It is now time for the inequalities, okay? And a system of inequalities, similar to a system of equations. How would you define a system of inequalities? You think? What's your opening guess? Nathan.
System with less than or equal to stuff.
Okay, it's less than or equal to stuff. You see a corner plane. Maybe you remember graphing inequalities before back in CO34. But a system of inequalities, it is going to be one, or as I say, multiple inequalities with a range of ordered pairs for a solution. Multiple inequalities with a range of ordered pairs for a solution. Now, we already know, if you think back to when we graphed inequalities before, that we have to shade one of the sides, right, to show all the ordered pairs that could potentially work. This is that dashed line, solid line, shade above the y-intercept, below the y-intercept thing, right? But when we're looking for a system of inequalities, we're looking for the section that is shaded in both inequalities. That's our solution set. Okay? Yeah.
What does that word? What is the last word?
Solution. Solution is what that says. Solution. So, steps to solving a system of inequalities by graphing. First of all, we are going to graph each inequality. If you need a refresher on that one, you look back at CO34. Okay, we're graphing each inequality, and then number two, our solutions. Well, let's wait for a minute. Let's do step one first. Y is less than 2x plus 2. Is this going to be a dashed line or a solid line? Dash. Which section of the corner plane is going to be shaded? Above the y-intercept or below the y-intercept?
Above.
Below, right? And everything that we need to know to answer those two questions is in our inequality symbol. Less than means dashed, and below. Okay? So we're going to start at positive 2 on the y-axis as our y-intercept there, 2x plus 2. And then our slope, remember this 2x is really like 2 over 1. So from that y-intercept, we're going up 2 and over 1. Okay? And I'm going to put a dashed line through this like that. And we are shading below the y-intercept. And so everything on that side is going to be shaded. Okay? So just a refresher of a general inequality graph. Are the ordered pairs on the line a solution to the inequality?
No.
No, that's why it's dashed. Okay? This is the line, but anything on the line is not actually a solution. Any ordered pair in this section that I shaded will work. Every ordered pair on the section I didn't shade will not work. Right? Nathan.
I feel like it should be the other way around because, like, if it was a solid line, then it's kind of like keeping everything in, where a dash is like, I don't know, like something.
Well, it relates to that open circle, closed circle thing. You know, the open circle is a less than or greater than symbol. This would be less than or equal to or greater than or equal to, right? So, I mean, it would kind of, that open circle, you know, you've got openings in the line here. Closed circle, it's all solid, it's all closed up. That means that the solutions are part of it. Okay. The next one I'm going to do in red, so we get some kind of different colors here. It might behoove you to use multiple colors as well, and you'll see why shortly. But the second inequality here, y is greater than 1/3 x minus 3. Tell me, dashed or solid? Dashed shaded above the y-intercept or shaded below the y-intercept?
Above.
Above. Okay. And again, everything we need to know for that comes from that greater than symbol. Greater than means dash. Greater than means above. So we're starting at -3 for our y-intercept, right? 1/3 x minus 3. And then from that point, we're using our slope up 1 over 3, and that's going to put us right here. Right? And we are using a dashed line to do that. And we are shading above. Now notice here, when I shade above this second inequality, I'm going to be shading some parts of the corner plane that aren't already shaded, but then I'm also shading some parts of the corner plane that are shaded. Right? Now let's review here. The green shaded area represents every solution to the green inequality, the one I did first. That's black. The green inequality, the one I did first. The red shaded area represents every solution to the red inequality, the one I did second. So where do you think we are going to find these solutions to the entire system? Great. In the green and the red area, where they overlap, where it's Christmas time, right? Green and red together. So these solutions to both inequalities fall in this doubly shaded section that I'm going to now shade blue to clearly identify. Okay? On the test, you need to be able to clearly identify where your final solution set is. So if you're only using one color, maybe on one of them you shade by making horizontal lines. The other inequality you shade by vertical, so you can see where they intersect, right? Maybe you want to erase all of this other stuff, so you're just left with where they overlap here. However you want to make it clear as day to me that is where your solutions are. That's what you should do. But if I can't tell what's shaded, where is it? I can't give you the point. So yeah, well,
We can shade in different colors.
you can use different colors. Yes. For you art people, this is your art project for try 2. Okay. So there you go.
This is our art.
This is your art project. Yes.
You're so good. This is
Cool.
not a good idea. Can we do more together?
We can indeed.
Not a
Okay.
good art
Can we do the
project.
bottom 3?
Yes.
We'll see how many we can get.
Yeah.
Give me a solution that is, or give me an order pair that is a solution. Colin? 1, 1 is 1, 1 in the, kind of hard to see now, but 1, 1 is right there. 1, 1 does work. Give me another order pair that is a solution. Paisley?
2, 2.
2, 2. Where's 2, 2? 2, 2 is going to be right about there. 2, 2 works. Okay. There are several, right? It's anything in that doubly shaded region. Okay. Questions? Comments, concerns, complaints, comments, congratulations, or criticisms? Colin?
What is step number 2?
Step number 2 is to, let's see, the solution is in the overlapping region. Thank you. The solution is in the overlapping region. Nate?
0, 0.
0, 0 is a solution as well. Correct. Thank you. Anything else? Okay. Let's go down. Solve each system by graphing. Write an order pair that is a solution. Y is greater than or equal to -3x plus 4. We'll do this one in green again. That's black. There we go. Is this going to be solid or dashed?
Solid.
Solid. Am I shading above or below the y-intercept, Cole?
Above. Below? No, above.
Above, right? That greater than or equal to symbol. Maddie?
Oh, I just had a question. For like on the test, if we don't shade the whole region, is that like
You should shade the, yes.
like you just missed a spot.
Depends on how big the spot is. I don't know. Kind of do your best to shade the entire part. Colin?
What if you, can you just
like only shade the region?
Yes, if you want to erase the other parts or in your mind keep track of what should be shaded, then only shade in the solution part. That's okay too. As long as I can see what your final solution section is, that's what I'll be looking for. So positive 4 is our y-intercept. There, the point goes there. Our slope is negative 3/2, so down 3, right 2. And we said this is a solid line coming through here. And we're shading above the y-intercept. Okay, so this entire section there. Then our second inequality, which we'll do in red, solid or dashed? Dash, above or below? Below, okay. So positive 2 is our y-intercept, there it goes. Up 1 over 3 for our slope. Okay, it's a dashed line. And we are shading below, which includes part of the graph that's not shaded, but what we're after, the part that is already shaded, because where those shaded regions overlap, that is where the solution to the system is. All the green works in the top equation, all the red works in the bottom equation. Where they overlap, right here, which I'm going to put in blue to make it clear as day, that is our solution section. Okay? And who can give me an order of pair that is in that solution section? Real. 3, 2, 1, 2, 3, 1, 2. That looks like it's in there. Very good job. And of course, there are others that work too. Tristan? 0, 6. 0, 6 is going to be up here on the y-axis in the green section. 6, 0, however, that will work. That will be in the solution set. Okay? Cool.
Wait. 5, 0.
5, 0 works as well. Will?
Hey, Joe. 4, 0.
4, 0 will work as well. Okay, Nick?
4, 1.
4, 1 will work. Colin? 7, 2, you said?
Yes.
Yes, that'll work. Nathan?
6, 2.
6, 2 will work. Obviously, there are several. Okay? All right, next one. Y is greater than 4x plus 6. Again, we will use my green pen tip is starting to flatten, so I'm trying to be smart and put the green pen in the black color slot, so that when I use the black pen, which is very sharp, it'll give me green. But my brain keeps grabbing the green color. But anyway, it's a war up there. That's why I keep grabbing the black one. Anyway, so y is greater than 4x plus 6, dashed above. Positive 6 is where our y-intercept's going to go. It's right there. And then up 4 over 1 from that point, using our slope. It is dashed, so down we go through here. And we're shading above the y-intercept, which is this entire section over there. Okay. Then our second inequality has the same y-intercept, also positive 6, but this time our slope is a little bit different. We're only going up 2 over 1 instead of up 4 over 1. So our slope will be here. Okay. Still a dashed line. And we're still shading above the y-intercept. So our solution set is this entire section here, where it's green and red together. Okay? Isn't this one fun? All the colors? I like it.
No.
I enjoy
Why
this
do you only use green?
Huh?
Why do you only use green?
I don't know. Black kind of blends in with the other print on the page sometimes. And then I use red and blue to highlight things. Green means go. Like, let's go. Let's do this.
Uh-huh.
Forge ahead.
Let's sure.
You know? So,
Yeah.
questions on this one?
Oh, we don't want our math packets yet.
You'll get your next math packet by the end of the week. Okay. Go ahead and do the last one on your own.
Oh, don't we need to raise the?
I think I need
Order
some
pairs.
scissors.
Yes, order pairs. You can write order pairs that are solution. But just before we run out of time, I want to make sure we get a chance for you do one solo. Go ahead and try the last one on your own. Graph each inequality. Find that solution section.
We have homework.
You will have homework, yes.
Is it the other, the back?
It is the second page of this. That is correct. Don't call it homework, call it practice. Opportunities.
No, homework. Because practice
We
you
have to
don't
do it at our
do.
home and it's making
What
us
about
work.
Yeah, we're already
After
here
Sunday
for
days, we have to
6
do it.
hours.
Could do it. I correct when I get home. I'm here for 8 hours.
So like jobs.
No.
Yeah, but you
Well,
get to
This
choose.
is your job, right?
But yeah, but you can
You
watch
can
while
use
you
the money
Yeah,
for
you
this.
make
You
me
can
money.
do other things like
Shut up,
that.
you're making money.
And you can quit.
That's
No,
rude.
Neither do we.
But we don't get
That's
paid.
so mean.
Spend money, you make money.
Mr. Chelsea walked in while you were playing.
I was. I played it, yeah.
Yeah, because you were sad because Mrs. Wheel doesn't like games.
No, she does not play my games. Thanks, man. Appreciate that.
You like
graph
Mrs. Sewell's
inequalities.
laugh?
What's that?
You like Mrs. Sewell's laugh?
Yeah. Catchy.
What, you don't? No, I
Paul can imitate it.
Can you do the evil laugh?
I can imitate it very well.
No. I don't need the evil laugh about it.
Yeah.
All right, let's go through this. -4 is our, well, let's do it again. -4 is our y-intercept, so there it goes. And then our slope up 2/5. It's going to put us right here. This is a solid line because it's that less than or equal to. And we are shading below the y-intercept because it's the less than family. So your first inequality should look like that. Okay. Check your y-intercept, check your slope up to right 5, shading below. Okay, should look like that. The second one, which we'll do in red, this one has a y-intercept of +1, so on the y-axis, +1. Our slope -3, which remember is at -3/1, so down 3/1. There's our second point. This one's going to be a dashed line, dotted line coming through here. And we are shading above the y-intercept, which is this entire section here. But what we care about, where these shaded regions overlap, I'll put that in blue, and that is this pocket down in the bottom right corner of the coordinate plane. Real? I don't know. I don't know what it is. We're not there yet. Okay? Questions, comments, concerns, complaints, compliments, congratulations, or criticisms? Will,
Congratulations
for what?
for being a good teacher. Your kind words are appreciated.
Nick,
Why don't you have a pencil sharpener in your room?
He's scared of
The
that.
accident.
Why would you ask?
was
Why would I ask? Because I
action.
need to sharpen my pencil.
Use scissors.
I could put the tabs off finger in it.
can't talk about that. Can't talk about that. Nathan,
Do you like paper poppers?
no, not what I'm trying to teach. Sam,
I'm gonna be gone. Do I still have to do like the bell ringers and homework checks?
when you're not in school?
Yeah.
No, when you're gone from school, you are excused from the daily bell ringers and homework.
Why don't you choose?
But I still have to do that, right?
You should follow along with the lessons. Yeah. Will,
I'm not gonna be here on Friday.
thank you. Neither will I. Actually, I will be here. Great. Caitlin, you're gone next week.
Yeah.
Let me get the practice test first. Would you be able to stay after tomorrow or Thursday? Okay. Yeah. Let me get the practice test first.
Would it be better for you to stay after?
That's up to you. We can talk about that later. Colin. So, shh. Okay, thank you. Very good. All right. Real had a question on one on the second page. Which one did you want to talk about? So, the 4 equations. You do it the same way as you would if you just had 2. You graph them all, and then you're looking for where those shaded regions overlap, where all 4 shaded regions overlap. There's one with 3 equations here, or 3 inequalities here. Same kind of thing. Graph all 3 of them. Your solution will be where all 3 overlap. Solving a system of inequalities with more than two equations or more than two inequalities is much easier than solving a system of equations. Okay, with a system of equations with more than two equations, we talked about that. That's you need x, y, z, three variables. It's a much longer process. Solving any inequalities, you're still graphing each of them, and you're looking for where all the shaded regions overlap. Okay, where they all overlap. Yeah. If they don't overlap, it means there's no solution to the system. Okay, if there's no ordered pair that works in both of them, which you'll see, if the shaded regions don't overlap, it means there's no solution. Okay, really good question there. Will,
How do you do the one next to it? The one on the right?
the last one?
Yeah.
It says, write and graph a system of inequalities that make a triangle. Check your answer on a graphing calculator. So if you don't have a graphing calculator, they're ones that look like these. That's okay. You can still write a system of equations that makes a triangle. So basically, there's a triangle, right? You could do that. You could do. To just get you started, right? Let's say I want my one line of my triangle to do like that, and then come down like this. Okay, so my equation would be y equals, my slope I used is -3/2, and then my y-intercept is +5. So I should use equal sign. We'll say y is less than or equal to -3/2 x plus 5. Okay, you've written equations before, right? You can pick whatever y-intercept you want to. There's your +5. The slope I use is down 3/2, which again I just chose. There's my slope there, and in this case, I'm shading below. So your next inequality, you might want it to come across like this. Maybe you put your y-intercept here, put your next point there, and it looks like this. Maybe your third inequality, you want to come down. So maybe we'll put my y-intercept at the origin. Did it again. My y-intercept at the origin, down 1/1. So that doesn't make a triangle, does it? Maybe I'll go up 1/2. So it comes like this, right? There's my triangle there. It's very free. You decide. You're basically graphing three lines that make a triangle, okay? And then make your inequality symbols so that your ultimate solution set is in between. Okay? It actually doesn't technically say that you need your solution in the. I should clarify that for next year. But three lines that make a triangle. Yeah.
So for all of them, do we need to put our solution?
It does. It does say in the direction of the top, I believe. Okay, that's all. That's our math.
Don't forget to like